What if I told you that the light bulletproof vest a police officer puts on every morning was born from a single cloudy liquid that almost got thrown in the trash? More than 3,000 law enforcement officers are alive today because one chemist refused to give up on an accident. Kevlar is 5 times stronger than steel, pound for pound stronger than any metal you know, yet it is lighter than fiberglass. It stops bullets cold, holds up spacecraft, and runs through your iPhone cables. But the woman who discovered it, she was just trying to make better car tires. Welcome to the InventIQ. Today, we are uncovering the impossible story of accidental discovery, of stubborn persistence, and of a single liquid that changed safety forever. The incredible story of Kevlar. A childhood dream that almost became fashion. Our story begins not in a lab, but in New Kensington, Pennsylvania, July 31st, 1923. A girl named Stephanie Kwolek is born to Polish immigrant parents. At age 6, she wants to become a fashion designer. She loves fabric, she loves sewing, she loves clothes. But her father is a naturalist. He takes her into the woods to collect leaves, study flowers, and press plants into notebooks. Two worlds, fashion and science. Then tragedy strikes. Her father dies when she is only 10. Her mother becomes the sole provider, and Stephanie leans hard into her studies. By high school, she is obsessed with math and science. Medicine grabs her attention. Chemistry pulls her in deeply. After college, she faces a hard choice. She simply does not have enough money for medical school. DuPont calls. She takes a job as a lab chemist, thinking it will just be temporary until she can afford medical school. But the moment she steps inside those walls, something clicks. Suddenly, medicine is forgotten. Chemistry has her, forever. The gas crisis mission that changed everything. It is 1964. America is bracing for a gasoline crisis. The entire auto industry is desperate to make tires lighter, stronger, and more fuel efficient. DuPont sets its sights on a new challenge. Replace the heavy steel used in radial tires with a lightweight fiber that is just as strong. Stephanie Kwolek's team is given this mission. She begins working with polymers, long, spaghetti-like molecular chains. Her assignment? Prepare intermediates, synthesize high molecular weight aromatic polyamides, dissolve them, and spin them into fibers. It sounds straightforward, but these rod-like molecules are stubborn. They behave differently from the flexible nylon everyone knows. They are hard to dissolve. They resist turning into a usable fiber. Day after day, experiment after experiment. Most would have given up, but Stephanie Kwolek is not most people. The cloudy accident everyone wanted to throw away. Let's freeze this moment. A laboratory in Wilmington, Delaware, 1965. Stephanie Kwolek is trying to dissolve a solid polymer. She expects to get a syrupy, transparent liquid, exactly like every polymer solution she has seen before, thick, clear, like molasses. What she gets is the opposite. The liquid is thin, it pours almost like water, and it is cloudy, almost milky, opalescent, strange, wrong. Every instinct in polymer chemistry says, throw it away. But Stephanie looks at that cloudy tube and thinks something different. She says later, I thought, there's something different about this. This may be very useful. Here is the genius. Most researchers see a failed experiment. She sees a clue. She asks her colleagues to spin this strange liquid into a fiber. The technician in charge of the spinning machine refuses. He says the liquid is too fluid. It looks like it has particles. He is certain it will clog the tiny holes in the spinning machine, holes only 1/1000th of an inch wide. He says no. Stephanie spends days pushing, persuading, and insisting. She will not back down. Finally, reluctantly, he agrees to spin it. What happens next shocks everyone. The moment they knew, it wouldn't break. The strange liquid passes through the spinneret. It spins easily, beautifully. And the resulting fiber is unlike anything they have ever seen. It is stiff. It is incredibly strong. Stephanie later says the threads were so tough she could barely break them with her hands, even before any formal testing. Then the real numbers come back. Pound for pound, this new fiber is 5 times stronger than steel. 5 times stronger than steel. Speaking about that moment, Stephanie recalled, "That's when I said, aha." But here is the heartbreaking part. Almost nobody believed it at first. The chemist in charge of the spinning machine had refused just days earlier. And even after the test, the industry was slow to accept that a thin, milky liquid could produce something stronger than metal. From that single test tube, it would take 6 years to bring Kevlar to commercial production. 6 years of more skepticism, more development, and more fights. But Stephanie Kwolek had already seen the truth. The fiber that would one day save thousands of lives. The patent and why she never became rich. Let's talk about money, because this part stings. Stephanie Kwolek invented a fiber worth billions of dollars. Today, Kevlar is used in over 200 different applications, from bulletproof vests to spacecraft to fiber optic cables. But the moment Stephanie discovered the polymer, DuPont filed the patents under its own name. She transferred the rights to her employer. That was standard practice at the time. On November 22, 1968, the German Patent Office received the application DE1810426 for mass and fibers or threads made from it. The patent described a superfiber 5 times as strong as steel. But Stephanie Kwolek was hardly involved in developing the commercial applications. She did not share in the enormous wealth Kevlar later generated. She never complained. She often said, "All sorts of things can happen when you're open to new ideas and playing around with things." But here is the larger irony. Kevlar was so strong and so stiff that it was actually hard to process on a large scale. The company struggled for years to find practical ways to manufacture it. Finally, in 1971, Kevlar hit the commercial market. But at first, the world did not buy it for protection. They bought it for racing tires and yacht sails. The life-saving application was still hidden in the future. The reluctant hero, how body armor was born. Here is where the story takes a dramatic turn. The U.S. National Institute of Justice, NIJ, had a problem. Police officers were being killed by handguns. The vests available were heavy, uncomfortable, and officers refused to wear them. Enter 2 men, Lester Shubin and Nicholas Wantanarelli, at the U.S. Army's Edgewood Arsenal. They heard about DuPont's new miracle fiber. They tested Kevlar and discovered that 7 layers of Kevlar 29 were both comfortable and strong enough for everyday police use. By the mid-1970s, the first lightweight concealable body armor was born. The NIJ ran a 2-year test with 5,000 police officers in 14 cities. The results were stunning. Kevlar vests saved 6 officers from death or serious injury during the test alone. Today, more than 3,000 U.S. law enforcement officers are alive because Stephanie Kwolek's accidental discovery was turned into a vest. But here is the quiet truth. The woman who started it all never got the credit she truly deserved for that life-saving leap. The transition from tire fiber to body armor was led by military researchers, not by Kwolek herself. And yet, none of it would have existed without her stubbornness in 1965. Modern impact, from police vests to Mars rovers. Fast forward to today, Kevlar is everywhere. Law enforcement vests, helmets, and shields, fighter jet body panels, NASA spacecraft, including the parachute systems that landed rovers on Mars. In your phone, Kevlar reinforces fiber optic cables and strengthens smartphone cases. In your car, it strengthens tires, brake pads, and timing belts. Firefighters wear Kevlar suits. Lumberjacks wear cut-resistant Kevlar gloves. Heck, even musical instrument strings and speaker cones use Kevlar to stop vibration distortion. And in a strange twist of irony, remember how Stephanie Kwolek started this journey because she wanted to make better tires? Decades later, Kevlar is exactly what you find in high-performance racing tires, bicycle tires, and even armored vehicle tires. The application that launched the search ended up being one of the last to adopt the fiber, but it adopted it. Fun facts that will blow your mind. Time for some jaw-dropping trivia. Number 1. Kevlar is technically a liquid crystal polymer. The molecules inside are rigid rods that align like soldiers when spun into a fiber. That alignment is what gives it its incredible strength. Number 2. Kevlar does not stop bullets the way you see in movies. The fibers actually absorb the bullet's kinetic energy and spread it across a wide area. The bullet is still stopped, but the vest dents inward. Officers can still feel the impact and often bruise or break ribs, but their organs survive. Number 3. Kevlar is heat resistant up to 450 degrees Celsius, about 850 degrees Fahrenheit. It does not melt, it does not drip. That is why firefighters use it. Number 4. Kevlar saved the life of a British Special Forces soldier who was shot 4 times in the helmet. The bullet that hit the Kevlar reinforced helmet was deflected. He lived. Number 5. Stephanie Kwolek was the 4th woman ever inducted into the National Inventors Hall of Fame, out of 113 members at the time, and she received the National Medal of Technology in 1999. Conclusion: why Kevlar is a true game changer. Let's return to where we started. A young woman who dreamed of designing dresses becomes a chemist by accident. She mixes a cloudy liquid everyone else wants to throw away. She convinces a skeptical technician to spin it, and what emerges changes the rules of safety forever. More than 3,000 US police officers are alive because of Kevlar. Countless soldiers, journalists, and civilians owe their lives to the same curious mixture of accident and persistence. When I first learned this story, I realized something. The biggest breakthroughs do not always come from carefully planned formulas. They come from people who notice the wrong thing, who refuse to discard the strange result, and who fight to see what everyone else overlooks. Stephanie Kwolek was one of the few female chemists at DuPont in the 1960s. Her male colleagues often assumed the inventor behind the Kevlar patents was a man. One chemist even said, "That guy who did the work in the patents had to be a very outstanding chemist." That guy was Stephanie, and she never stopped. Thank you for watching The InventIQ. If this story changed how you see the everyday objects around you, hit that like button. Share it with someone who thinks science is boring, because clearly it isn't. Subscribe to The InventIQ right now. Turn on notifications so you never miss the hidden drama behind the inventions that shape our world. And write in the comments, which invention do you want me to uncover next? Steam engine? Penicillin? The microchip? Tell me. Next week, we are diving into another story of persistence, failure, and accidental brilliance, the kind that makes you wonder how we ever lived without it. Until then, stay curious. And remember, even the wrong liquid at the right moment can save the world.